Assalamu alaikum. Our lecture for today is Materials and Systems for Prestressing. Contains definitions used in prestressing reinforcement, stress relief low relaxation wires and strands, high tensile strength prestressing bars, stress strain diagram for prestressing steel, typical determination of yield strength for a prestressing steel, summary of minimum properties of a prestressing tendons bars, strand versus mild steel bar reinforcement, characteristics of a prestressing steel, definitions used in prestressing, wires, strands, tendons, cables, bars. Wires. Prestressing wire is a single unit made of steel. Strand. 2, 3, or 7 wires are twisted to form a prestressing strand. Tendon. A group of strands or wires are twisted to form a prestressing tendon. Cable. A group of tendons form a prestressing cable. A prestressing reinforcement have a high strength steel equal to 270 kSa. Normal prestress losses equal to 35 to 60 kSa. May lose 15% of stress in high strength steel due to losses versus equal to 80% in mild steel for same conditions. Three main types of prestressing reinforcement in US: uncoated stress relief or low relaxation wires, uncoated stress relief strand and low relaxation strand, uncoated high strength steel bars. Here we can refer to stress relief. Strand or wires means that the strand show the phenomenon of releasing stress more than low relaxation strand with in the same constant strain. Stress relief low relaxation wires and strand. ASTM A421 was for cold drawn single wires, and for strand ASTM specification A460 7 wire strand. Most popular GR means point of failure 270 with 0.5 inch diameter 7 wire strand made by twisting 6 wire around a control wire. GR 250 with 0.25 inch to 0.6 inch diameter. GR 270 with 0.375 inch to 0.6 inch diameter. Standard and compacted strand sections. Here we can see 6 wire twisting around the control wire, and here we can see 2 layer of 9 wires twisting around the control wire. And according to Archimedes' principle, we can find out the area of strand which have a known length from the weight of displaced water. Here compacted and here standard. In this video we can see multi-strands hydraulic jack and pump for post-tensioning bridge girder. Here we can see the strand made by 6 wire twisting around the control wire here. High tensile strength pre-stressing bars. ASTM A722 was for smooth or deformed bars, grade 145 or 160. Available diameter is 19 mm to 35 mm. Cold drawn rises yield strength and stress relief by heating to increase ductility. Stress strength diagram for prestressing steel. Here we can see stress strain diagram for type of prestressing strand and wires, and we can see here a grade 270 strand, and here 250 strand, and here for wires with 0.192 inch diameter, and here for grid 160 alloy bars, and here the modulus elasticity for each type, and here we can see the measuring of yielding strength for each type by this hidden line with elongation 1%, and here for just grid 160 alloy bar with 0.75%. Because yielding of a prestressing steel is not well defined, their yield strength is determined according to strain criteria. Current ASTM standards specify that the yield stress of a prestressing wires and strand should be correspond to a total strain of 1%, while the total strain of 0.7% is recommended for prestressing bars. Typical determination of yield strength for a prestressing steel. 3 partitions of a prestressing stress strain curves. Here we can see in the beginning initial linear partition up to proportional limit, non-linear partition with decreasing slope, and then final strain hardening slope that is nearly linear with a small positive slope leading to failure. Another often used method to determine the yield stress is called to offset strain method. In this method, the yield stress corresponds to a permanent plastic strain of 0.2% or 0.1% depending on the standard used. Theoretically, the proportional limit corresponds to the point at which the initial partition of stress strain curve deviates from linearity. In practice, however, the proportional limit is generally determined by the stress corresponding to a permanent non-recoverable or offset strain of 0.01% or 0.02% depending on some specifications. The modulus of elasticity of steel, here in this figure, the previous diagram, the modulus of elasticity of steel is essentially a constant independent of strength. However, slight differences exist between the elastic modulus of prestressing steel. Straight wires as reinforcing bars generally show the highest modulus because of allowing the modulus of a prestressing bar is smaller. We can see the modulus of elasticity for each type here. Summary of minimum properties of prestressing tendons bars. Here in this table we can see the property of prestressing tendons. In the first column, the type of prestressing steel, and in the second column we can see the ASTM standard for each type. Here strand stress relief, here low relaxation. And in the third column we can see ASTM minimum specified yield strength or elongation at failure. Yield strength equal to 0.85 from FBU, ultimate strength. And here for each type of strand, stress relief, low relaxation, in the first one, FBY equal to 0.85 FBU at strain of pre-stressing steel equal to 0.01. And here for low relaxation, FBY equal to 0.9 FBU, also in the same strain 0.01. Finally here we can see the yield strength for smooth bars equal to 0.85 from FBU, and here for the deformed bar equal to 0.8 from FBU at strain 0.007 for each type. And here we can see the elongation at failure equal for all strand and wires 0.04, here 0.04, just here for bar equal to 0.4, not 0.04. And here we can see the gauge length. It means that it's the distance between the two ends of the scale that measures the elongation. Here in the first one equal to 10 inch, and here for the strand equal to 24 inch, and here equal to 20 bars diameters. And here the elastic modulus for each types of pre-stressing steel. In the final column we can see the proportional limit FBPP at 0.01% offset strain equal to for wires 75 to 85% of minimum specified strength, and here for strand equal to 70 to 75% of minimum specified strength, and here finally for bars equal to 60 to 65% of minimum specified strength. Strand versus mild steel bar reinforcement. Here we can see the diagram of stress strain for pre-stressing steel and mild steel, and we can see in the pre-stressing steel here the diagram beginning not from zero with a value refer to camber of a pre-stressing steel, and mild steel beginning from the 0 point. Also we can see pre-stressing steel as it quickly breaks because it does not have a ductility, and the mild steel we can see its failure at strain 0.02, and for pre-stressing steel at 0.04. The strain failure is low when it compared with the mild steel. More this number, the pre-stressing steel it will break. Characteristic of pre-stressing steel: higher strength than mild steel, lower failure strain than mild steel, yielding behavior is not well defined, relatively high proportional limit. Thank you.